Welcome back to the DASYLab training. This training will make the most sense if you have watched the previous modules. Module 3 of the DASYLab Basics class looks at controlling the data flow. We'll use triggers and relay modules to affect that. We'll also look at the switch module as a way of controlling the relay. We'll also do an example with some of the different mathematics functions and look at statistics and how statistics are different from mathematics in DASYLab. The trigger group includes the pre-post trigger, the combi trigger, the relay module, and the block relay module. The block relay is new in DASYLab 2020. We also have 3 special case triggers: a start-stop trigger, a trigger on demand, and a sample trigger module. We'll work on an oscilloscope type example where we're going to use a switch to control the relay. We'll create a new worksheet with an analog input, create the switch, add a relay module to control the data flow, and to allow a snapshot based on a trigger from the switch. We'll look at it in a YT chart, like an oscilloscope, and a chart recorder to compare. With a new worksheet, I'm going to create an analog input from the Measurement Computing group. I'll select the analog input, drag it out, drop it. This is a USB 201. I'll select the channel group and click OK. I've set up so that I automatically load or open the properties dialog when I create a new module. So this is a device that's collecting data at 1,000 samples per second. The block size is 100 samples. And I have got a sinusoidal wave coming in at a relatively slow rate. So click OK. I have the analog input now, and now I want to add the control functions. The first control function is simply the relay module. Drag out the relay module and drop it. It asks what kind of a relay you want, with control input or action controlled. This example is using the default, the relay with control input. Click OK. The relay again opens and it gives you very few choices whether you want to remove the data or replace the data with a default value. We're going to stick with the remove the data so that we will see gaps between the blocked data areas. Click OK. The relay has an X input and a 0 input. X is the control input, 0 is the data input. You can connect the analog input directly to the 0 input. And now I need something to control it. And I said I was going to use the switch module. So go to the control group over on the left and drag out a switch module. The switch module has got a couple of different modes. We'll start with the on-off switch and click OK, drag it up, connect it to the X input. So the switch is the control. The analog input is the data that we're going to control. I'll restore the switch module from below, and now you see I have this on-off switch. I can click it before the measurement starts just to show you how it works. Now I want to visualize the data. We'll go to the display group and we're going to make 2 modules, a YT chart, and this is just a single YT chart. I'll click OK, and a chart recorder, and click OK. So in module 2, I showed you how to do the pass-through. In this demonstration, I'm just going to split the data wire. You split the data wire by clicking on the wire coming out of the module, and then you get another wiring tool, you connect it over to the recorder. You can move this dot, this node, by clicking on it and dragging it to where you want it to be. So I've got 2 displays. I need to restore those and bring them into the recording area. So I have a YT chart on the left and the chart recorder on the right. Now if I click the Start button, I should see an error message. What was the error message? I am displaying error messages at the moment in my console. It says the time information or block length of the input channels don't match. The channels can't be linked in this module. Stop. This is coming from the relay. So the relay is saying my inputs aren't coordinated or synchronized. Well, the error is not in the analog input because I want that sample rate. The error is going to be in the switch module. So open the properties for the switch module. And in the options of the switch module, the bottom half or the bottom third of this dialog box shows you synchronization. The synchronization time-base settings, it's currently using the DASYLab time-base. To coordinate it, I'm going to select the USB 201 input HW time-base, which is what the analog input module is using. Click OK and click OK, and we'll try again. So now I have got, where'd my YT chart, no data showing on any of my charts. I'll click the On button, and now I'll start to see data showing up, and that's way too slow, isn't it? Let's increase the frequency here. All right, so now we've got a sinusoidal type waveform coming in. I can increase the amplitude on it and take it up to about, yeah, so you can see it. You can see it on the chart recorder. You can zoom in on the chart recorder, but the YT chart is only showing you 1/10 of a second at a time. So we're not seeing the entire waveform. If I increase my waveform sample rate to something a little bit larger, now you can see that I can get the full cycle of the sine wave showing up in the YT chart. All right, so that worked. Turn it off. So now what's happening is both the YT chart and the chart recorder display have stopped. If I click on again, the YT chart doesn't show you any discontinuity, but the chart recorder does. It shows you a gap in the data for the duration that I was stopped. So if I come up to the front again and I click on, there's going to be a jump, click off. Now I can make this much more visual by showing a single block of data being released at a time as opposed to showing you a bunch of blocks of data. So I'm going to click stop and change the type of switch. So this is the switch properties. Open the module properties for the switch and change it from an on-off switch to a one-shot switch. This makes it a momentary switch where you click it, it will stay on for a block of data and then go off again. And the block of data is determined by its time base. In this case, it will stay on for 1/10 of a second. So click start, everything's going to clear, and I'll click the on button and I'll get a data sample. This is a block of data that came in. I'll click the button again and I'll get another sample. So now that you can see on the chart that I've got that same thing that I look at in the YT chart displaying. I click again, you'll get the same display, and the difference is that they are spread out. So that if I zoom in on the minute worth of data in the chart recorder, you can see that I had 4 clicks, 5 clicks, 6 clicks, 7 clicks, and there are gaps between each of the clicks. So that's how the switch module works. There are a couple of other modes in the switch module that you could play with. They include the on-off switch, the one-shot switch, a button. The button is just, it looks the same as the one-shot, but it just is a toggle on, toggle off. So this is really the same mode with a slightly different view as the on-off switch. And the last of the 4 switch modes is push button. If I click start, as long as I hold the button down, it will stay closed. So you can do burst modes here, but more typically, I work with a one-shot switch to be able to get a short burst and the switch immediately goes off again. So that's a simple view of an oscilloscope type of function. Save this worksheet, and we're going to do switch relay is the example. Next, I want to modify this same worksheet example by adding a combi trigger, a second relay, add a channel to the chart recorder, and add a second YT chart, and we'll wire it as shown. This will allow us to look at the difference between how the switch works and the combi trigger works. So starting with this same worksheet, I will first minimize all the display windows. I want to add a combi trigger module from the trigger functions group. I'll drag it over. It has 2 types of triggers, whether you have 1 input or 2 inputs. I'm going to be working with the same data stream for the trigger and data and start and stop. So click OK. I want to set this up so that I look at my signal in some way. And a simple way to do it is to say, let's just look at the positive part of the signal. So if I look at the signal as it rises above 0, and then as it falls through 0 again, we use the word undershot, then I will snapshot just the positive form of the signal. When I use both a start and a stop trigger definition, I don't also need to use the pre and post trigger values at the bottom of this dialog box. So click OK. I will branch the wire coming from the analog input to the combi trigger. Now I need a second relay, so I'll drag out a relay module. Again, a relay with the control input. Don't need to do anything on this dialog box. I will control the relay with the output of the combi trigger. The relay has the data input and I want to use the same input, which means I'm branching around the combi trigger to the relay. Now I said I want to add a channel to the chart recorder. So I'll just click the plus button to add a channel. I'll wire the output of the second relay to the chart recorder. And then I need to add a second YT chart to be able to get the oscilloscope display associated with this. Don't need to do anything here. I am going to branch the wire coming off of the relay into the second YT chart. And remember, if you don't like where the wires are, you can move them around. And I find I like symmetry. So I need to restore my displays again. I have the new display, which is the second YT chart, and I have the original YT chart. So I can make these make more sense on the screen by swapping where the recorder and the YT chart is. So the chart recorder is showing me 2 traces, a blue one and a red one for the input. And then I've got the 2 YT charts. So if I click start, right now, the YT chart that I just created is showing me just the positive segment of the signal. If I slow the signal down, the positive segment increases in width. If I increase the frequency, then the positive segment decreases in its width. And that's just simply a function of the frequency of the signal. It's all in dark blue in the chart recorder, so if I zoom in, you can see I'm just getting a snapshot of the top of the signal. Now you notice there's nothing in the first channel on the chart recorder, and there's nothing in the first YT chart. If I click the switch now, I can start getting little bits of the signal based upon when the switch is clicked. This tends to be block aligned, so it's certainly not going to match the second signal, but it gives you a difference between a manual control with the switch and a combi trigger control where we're actually looking at the data and selecting the data based upon some condition. Now, one of the things that you can do is you can look at what the settings are, but you can't change them at runtime. So I'm going to click OK and stop the measurement and open the combi trigger properties. And this time I would like to see the signal as it exceeds 2, and then as it falls below -2. So I'll get a distorted piece of the signal. Again, click Start. And now what I'm getting is the signal rises above 2, and then it stops as it falls below 2. So this gives you a snapshot of the signal in 2 different ways. And that's the thought here is to give you some sense of how to control your data flow. With a switch, you are controlling what data is going to the chart recorder and the YT chart manually. So you have to click the switch. This is typically used in applications where you don't want to write data to a file until you have visualized some condition on the screen. The combi trigger allows you to do it based on the values in the data. And you have a lot of control here. You can determine different threshold conditions. Greater than and smaller than are absolute values. Anytime the value is above your threshold, this will trigger. Anytime it's below the threshold, it will trigger. Threshold value exceeded and threshold value undershot are more movement conditions. It has to come from below the threshold to above the threshold to meet the exceeded condition. And similarly for the undershot, it has to come from above and go below. We have 2 shortcuts, rising edge and falling edge, that allow you to use an edge-based condition or a movement condition. And an edge is typically defined within DASYLab as rising from 0 to 5 or falling from 5 to 0. Never is a very special case where this won't trigger, and directly is another special case where it will immediately trigger. If you want to use the directly condition, it's easy to see that if you say your threshold value is exceeded at 2 and then you want to stop directly, then you need to look at how much time do you want to see, how many values do you want to see pre and post triggers. So say, for example, I would like to see, what are we sampling 1,000 times a second? I'd like to see 100 samples before, and I would like to see 50 samples after the trigger condition. So how does that look when I do that? I'll click Start, and now what I'm getting is a variable amount of information coming into the YT chart based upon how the trigger conditions are defined. And if you can see the animation on the relay say that it's re-triggering multiple times, and you're getting, it looks like 2 or 3 blocks. It's going to be 3 blocks per trigger event because of the block size. No, 1.5. So if instead I make the pre-trigger 25 and the post-trigger 50, then I should see something that looks more like a standing wave. Again, the total number of values coming out of the relay will be a block. And so we've reblocked the data from 100 samples down to 75 samples, 75 milliseconds. Okay, that is a really quick introduction to how triggering works, how the relay works, and how the 2 different displays interact with the 2 different types of relays in one worksheet example. As with the previous example, let's do a file save as, and this is going to be switch, relay, and trigger. Now this will let you go back and look at these examples if you need to figure out what it was that you did.
The next topic is to talk about the mathematics and statistics functions in DASYLab. The mathematics functions operate on one or more data values at the same point in time. So, for example, you could compare two channels, you could add two channels, you could do mathematics on one channel. Statistics functions operate on multiple samples on one or more blocks of data. The average module you would think would be statistics, but it's in the data reduction group, and we will talk about it as a form of data reduction. So we're going to do an example with formula and statistics, just talking about some typical functions. We'll create a measurement computing analog input and display it on a YT chart. I will use a formula interpreter and set it up to do an absolute value of the incoming signal. And then I will do a statistics module to look at the RMS, mean, and maximum, and use a chart recorder for the display. I'm also going to add a digital meter to see the statistical values as a snapshot in time.
Start with a new worksheet. We will need an analog input, so once again I will go to the input-output group, measurement computing, and drag out an analog input. The USB 201, I'll select the channel group and click OK. This continues to be 1,000 samples per second with 100 samples per block. And the USB 201 doesn't have a lot of settings that you can make, so there's nothing to do here. Click OK, and next I want to look at the formula module. So I'll close the input-output group and open mathematics. In addition to the formula interpreter, there's an arithmetic, a comparator, a trigonometry, a scaling, a differentiation integration, logic, bit mask, flip-flop, gray code, slope limitation, and reference curve functions in mathematics. I want to use the formula interpreter because it is the most general purpose mathematics module. Like the other modules in this group, it operates on one sample in time at a time. Unlike most other modules, it has a separate configuration for the number of input channels, and then the channel bar defines the number of formulas that you want to use. So you could have up to 16 formulas working on anywhere from 1 to 16 inputs. So I'm just clicking the plus sign, or you could just type a number in here. We'll go back to one input. So this formula, I want to do an absolute value, and I'm a lot like many of our customers. When I look at any dialog box that opens up with a big blank area and no clue what to do, I really dislike it. This is a very flexible module, so instead of giving you a whole bunch of radio buttons and selectors, we have given you an area where you can type in a formula. We try to make it easy for you. There are buttons underneath the formula box that allow you to select from available functions, trig functions, standard operators, constants, the number of inputs, as well as variables. We can use global variables in this function. Absolute value is a function. I have that memorized. When I click on functions, I get a bunch of buttons. Square, square root, absolute value, sine, truncate, fraction, round, rand, exponent, log n, and log. Okay, what do these all mean? You can click on help here. This is one of the many places in the help that it's helpful. Let's make it all fit in the dialog box so you can see it, or in the recording window. The list of functions is here. So we've got the common log, we've got the natural log, we've got exponential functions, square, the square root, number of digits, truncate, decimal places, integer value, absolute value, And when you open absolute value, you can see that absolute value is the function. It returns the absolute value of the argument. In effect, it strips off the minus sign and just leaves the number as a positive number. So this helps you figure out what these functions and these shorthand function names mean. I said I wanted absolute value, so I'm going to click ABS. ABS is dropped with a pair of parentheses, which is a good hint to say that this needs an argument. I want to do an absolute value of the input. I also have a button that has inputs. I can select any of the available 15, 16 inputs, but if you've only got one defined, then you can only select one. So I have a formula that's the absolute value of the input 1 or input 0, first input. Click OK and connect it up, and we'd like to see this, and I'm going to do this in a YT chart. So go to the display group, pull out a YT chart. I want to look at the original channel and then the computed channel. So I'll add a channel to the YT chart. I'll branch the original channel around to the YT chart, and then I will connect the formula to the YT chart. So we can look at this now. I'll restore the YT chart, move it into the recording area, and right now the YT chart is showing you both data channels in the same drawing area. I can make this look more like the chart recorder by clicking on the Many Windows button, and now I can see, depending on the frequency of the signal, let's slow this down a little. So now you can see you've got the full signal with the positive and negative components of it, and then you've got the absolute value signal, which just shows you the positive values associated with the negative value. So we get a whole bunch of half sine waves instead of a full sine wave with the negative component. So that was pretty straightforward to set up. I stopped the measurement, look at the properties for the formula module again. You can type anything in here that you want. You've got available functions, you've got the trigonometric functions, you've got operators, the standard operators, including raised to the power, times, divide, mod, addition, subtraction. You've also got comparators here. Is the value less than or greater than another value? I want to make a note while we're looking at this that the result of a comparison is 0 or 1. It's not 0 or 5 like the other logic functions in DASYLab. So you would need to pay attention to that, and if you needed to have a 5, multiply the result by 5. So 0 times 5 is 0, and 1 times 5 is 5. So the comparison functions, the not, and, or, and XOR functions also are logical functions, so they give you a response or a result of 0 or 1. The inputs allow you to select from any of your configured inputs, and constants gives you easy to access pi, e, true, false, and parentheses if you don't like typing. Variables, you can select from any defined variable. We don't have any defined at this point. Order of operations is defined in the help. It is standard programming order of operations where functions like the exponent will take precedence and be done first, followed by multiplication and division, followed by addition and subtraction. You can verify that by looking at the help and looking at the operator priorities section in the help, where it will tell you that the parentheses are the first, functions are second, not third, raised to the power is fourth, a multiplication, division, and modulus is fifth, addition, subtraction, sixth. Any of the logical operations, the comparison is seventh, and is 8, XOR and OR are ninth. We do recommend that using parentheses helps ensure that you know that you're going to get the result. You don't need to sweat the order of operations if you've already used parentheses to force the order of operations. So we got that. Now, that's fairly straightforward, fairly simple. I could have done the same thing in the arithmetic module with the exact same result, but I wanted to show you this function in the formula module. The next function we want to look at is statistics. The statistics group includes statistical values, histogram, in DASYLab Pro, rainflow, and two-channel classification. It includes counter module, pulse analysis, min-max. You can sort your channels, and you can also do the other side of reference curve with checking reference curve. Statistical values is a block-based function where you will look at one or more blocks and you define that, or you can do this cumulatively, and you can compute a number of values, the minimum, the maximum, RMS, mean. So what I'd like to do for this example is set up statistics to do 5 different computations. Add 4 channels so that you've got 5 total, 0 to 4 are defined. Channel 0 is going to be minimum. Channel 1 will be maximum. Channel 2 will be the RMS. Channel 3 will be the mean. And channel 4 will be peak to peak. This is a good time to name your channels because you've transformed them away from what they were originally. So we had the analog input, and now we're going to do statistics on the analog input. So on channel 0, I can give it a channel name. I can select and delete the value that's there, and I can do AIN 0 maximum or minimum. And then I can do this for each channel in turn. AIN 0 maximum. AIN 0 RMS. AIN 0 mean. And finally, AIN 0 peak. Let's make these the same. AIN 0 peak to peak. I was briefly interrupted so that you'll see that I have saved this worksheet as Math and Stats, and now I've reopened it to be able to continue with this lesson. So now I have the statistics module with 5 computations. There are 5 inputs to it and 5 outputs to it. It's a little bit frustrating, but you have to branch the wire multiple times in order to do this kind of computation. So I'm going to select, and then I am going to click on the wire multiple times in turn, and I like to click on corners to keep the wires tidy. So now I have a statistics module that's got 5 inputs and 5 outputs. First, I want to look at this in a chart recorder. So I'll drag a chart recorder out, and I need 5 channels on it. 0 to 4 are now configured. I'm going to do the copy inputs to create a pass-through. I'll wire this up quickly by doing the touch and connect, and then I'm going to create a digital meter to be able to give us an instantaneous readout of the current value. Click add the channels, click OK, and wire it up. Now I need to restore everything and rearrange it. So here's the digital meter. Here's the YT chart. Let's make that a little bit smaller. And here's the chart recorder at the bottom. Let's see how this looks. Click Start. Now I've still got my absolute value going on in the chart recorder, or the YT chart at the top. My chart recorder is showing a number that, this is kind of hard to read, isn't it? Let's overlap these. Now let's just make it bigger so we can see it. The top value here in blue is the maxima. So you can see that the maxima is showing that it is about 4 volts. The minima is a negative 3.9. That's channel 0, the red channel. And so that's down here at the 3.9. The RMS is 2.9, and that's the pink channel. So the RMS is hanging around here depending on the frequency of the signal. It's varying very little. The mean is the green signal, and the mean is varying around 0. And then the peak to peak is, the peak to peak is 7. I'm not able to see it on the chart, so I went back to multiple charts to see what the problem was, and the problem was the range. This is 7.9, so I am going to change the range from 0 to 10 to be able to see the peak to peak. So the peak to peak is staying right about 7.9. So the minima, the maxima, the RMS, and the mean. Now you can see on the legend of the chart recorder, I can see those channel names, but I don't see those same channel names on the digital meter. This is one of the changes you can make while running. I'll double click on the digital meter to open the properties dialog. I'll go to options and I'll ask DASYLab to show the channel names, and then to keep it compact, I'll put the unit in the same row as the data value. So I'll uncheck unit in separate row while checking channel names. Click OK, and then click OK. So now I have the channel names: min, max, RMS, mean, and peak to peak. So that's a quick look at two functions that are similar but different. You've got the absolute value, and then you've got the statistics module. Now, the other thing that you can do with statistics is you can change it to compute a different number of blocks or to go cumulative. So if we go to a cumulative min, max, peak, so you need to change this for each of the channels, it will look back and compute the statistics based on all the data received to this point. We'll restore the chart recorder so we can see how it is going to work. So what should happen now is these values stabilize very quickly. So you've got a peak, you've got the minima, you've got the maxima, you've got the RMS, the mean stabilized after a little bit of wiggling, and the peak to peak stayed very steady. So now if I change the amplitude by increasing it, you can see that it's going to make that change. And when I decrease the amplitude, it doesn't come back down again. All right, stop the measurement and minimize the display. And that's it for this example.
I'm going to finish this module with a different look at statistics, looking at the counter module. At the same time, I want to show you using the combi trigger to control a digital output. Now, you can't see my hardware. You're going to have to trust me on this one. I'm going to create a measurement computing digital input channel, create a combi trigger looking for a rising edge and holding for 10 seconds. I'll output to measurement computing digital output on channel 7. And then I will connect the input to a statistics counter, and I'll use the MCC digital input and a physical switch to count the button presses. So what will happen based on the combi trigger is the digital output will go on and light an LED on my USB 201 for 10 seconds. Now you would need to have some sort of a switch or contact closure on the digital input and a LED on the digital output to be able to visualize this. But we'll be able to see the results of the counter on the screen.
Starting again with a new worksheet, I will go to the Input-Output group and create a digital input. I'll select the digital input port channel 0 through 7. The USB 201 only has 8 bits of digital I/O, which are individually addressable. So we will use both the input and output on the 8 bits. So click OK. It's going to prompt you for the channel settings I want to acquire on channel 0. I've got it set up to acquire at 10 Hertz with 1 sample per block. It defaulted to 100 Hertz, so if you click on Measurement, you would go to the Measurement menu, click on Modify, and select 10 Hertz, and then it defaults to a block size of 1. Click OK. Next, create a chart recorder from the display group to be able to visualize the data. A single channel and connect it. I want to create a combi trigger function to be able to hold the state of the switch to 10 seconds. So this is just a simple way to take an instantaneous event like a rising edge, and then I'm going to directly turn it off. It will go on the rising edge, and then it will turn off after the settings at the bottom of this dialog box. I'll choose seconds, and I want to leave it on for 10 seconds each time this module detects a rising edge. Click OK. I will wire that up. This is going to control a digital output. So back to the Input-Output group, create the digital output, and select the same port. And now you see channel 0 is already in use. It's in use by the digital input. I have wired my device to use channel 7, so I'm double-clicking on 7 to enable it, and then I will double right-click on channel 1 to disable it. This will update at the rate coming into the module. So it's going to use the rate in effect from the digital input at 10 samples per second. Now I would like to count the number of times I click that switch. So I'm going to go to the Statistics group and open up the Counter module. And the Counter module is different from a hardware counter function. This counter function allows you to count blocks, samples, edges, the time for a high or a low, a maximum, minimum, extreme values, or zero crossings level comparisons. So I'm looking for rising edges. I want to count rising edges cumulatively. Blockwise or per value, in this case, it's going to be the same number because my block size is 1. So I'll leave it at blockwise. I'll branch the wire to go into the counter input. Now I want to visualize this information, and I'm going to do that in a digital meter. So click and connect it. And now I've got the function set up. I'll restore the displays and bring them into the recording area. And this is a little click switch. So I'm reading 0. I'll click it once, it will go high. I'll click it again, it will go low. I can see that my LED has stayed high. I'll click again and go high. Click again and go low, and you can see that I'm counting the number of times that I have clicked the switch. So the mechanical nature of the switch keeps it from clicking too quickly. That's one of the reasons I use 10 samples per second to measure this, because I know that the mechanical switch was limited. So now you see I've counted 10 times, and my LED is on, and it will go off again after 10 seconds. And here's a short video showing that I can click the switch and the LED goes on, and it takes 10 seconds for that LED to go off again. So waiting for that, it's off. I'll click the switch, the LED immediately comes on again. I've unclicked the switch and waiting another 10 seconds for it to go off.
At the end of Module 3, at this point, we have learned how to navigate the DASYLab work area. You've created, you've edited, you've removed, and you've moved modules. You've done some basic applications. You've created a data logger. You've created a simple oscilloscope. You've been able to replay your data. You have done some simple data reduction. The instant you put a relay on the work area in association with either the switch or the combi trigger, you are removing data. And we've done some files and file naming. The signal analysis that we've done has used math and statistics modules. We've looked at the formula, and we've looked at the statistical values module. The next module, Module 4, will cover signal analysis, including the frequency analysis module and its related functions, digital filtering, as well as different types of data reduction.